are going to do percent graphs 1 and 2 today. And let's go ahead and look at that. So we'll start with percent graphs 1, and I have mine printed and out in front of me. So in class, I had student groups work together to come up with some solutions on this. And so now we're going to discuss it and see what y'all think. So it says match each graph with a scenario and a function rule. So let's see, you put 600 in a bank account that earns 5% interest. You put 600 in a bank account that earns 3% interest. You put 1,000 in a bank account that earns 5% interest. You put 1,000 in a bank account and earns 3% interest. So what do all of these have in common? All the scenarios.
They all have a percentage.
Okay, so there's a earns percent interest. So that word earn. So if you earn money, what's going to happen to your bank account balance? It's going to go higher. So this is called the increase or growth. Let's go ahead and look at these scenarios. You buy a car for $20,000 that depreciates at a rate of 30%. You buy a car for $20,000 that depreciates at a rate of 20%. You buy a computer for $2,000 that depreciates at a rate of 30%. You buy a computer for $2,000 that depreciates at a rate of 20%. So what do all of these have in common?
Which one? The bottom? The bottom?
Yeah, the bottom one, 6 through 9.
Decrease.
Yeah, depreciate. What does that mean about the money?
It's gonna go down.
Going down.
Or people are taking it out.
So this is called a decrease. As soon as you drive a car off the lot, it automatically depreciates because it's no longer considered new. It's a used car at that point. So these are depreciates. These are earning, and which is an increase. So we have different scenarios. So all of these scenarios deal with increases. All of these scenarios deal with decreases. And can you see that in each of the graphs too? So these are all going up, and these are all going down. Okay. So whenever we look at the top, we want to match these scenarios with a letter. So how is one way to kind of narrow it down for this first one? 600 starts at 600 and 5%. How do you know this is different from those? Yeah,
The
yeah.
600 at the bottom.
600, yeah, because what would be the top one? Okay, so let's go ahead and put that. So the 1,000 right here, and so this would be 600. Based on the situations that we have to kind of look at. All right, from there, how do you know? So both of these are 600. So 1 and 2 are either C or D. So now how do you narrow it down?
The interest goes up.
3%, does that go up faster or slower than 5%?
Lower.
So this one's slower and this one's faster. So then 1 would be which one? C. 2 would be D. Okay, now the next one. The next two actually both have 1,000 interest. $1,000 balance, and then one has 5% interest, one has 3% interest. So which one is faster? A, so that goes with which one? 3. And so then this one would have to be the other one, B. So this one's slower. So just by looking at it, we don't even have to put in the calculator or anything like that. So now we need to look at the function rules. So all of these have f of x is a number times 1.0 something to the x power. So since they're in that form where you have a number to the x value, we know that they're exponential. But why is this 1.03, 1.03, 1.05, and 1.05 when all of these are 5%, 3%, 5%, 3%? Because it has to be increasing. If it's just 1, is it going to increase at all? It's like multiplying something times 1. You want to multiply it times something above 1. Above 3% above 1. If you think about percentages, if you do 100% of something, what do you get?
100%.
Which is just your original, right? Whatever it's capable of. But what if you do 110%? Plus 10% would give you 110 or 1.10. So you're increasing. So think about, everybody always says, give 110%. You know, you give what you are capable of plus a little bit more. So that is an increase. 100% is just what you have. 10% would be more, an increase. So that's why we would add that 1 on there, because we're talking about 100%. So if this is 5% interest, then it's 100% plus the 5%, which equals 105%, but then we convert it to a decimal, 1.05. And it starts at 600, so that's your first number. So this is your start. And then this is your percent with the 100% on there. So this would be number 1. Is that right? Okay. Which would be what? C, right? So I actually need to put both of them, right? I probably only need to put C on there, but I like to attach it to the scenario too. All right, 600. So D, 600, and then the 3% interest. So we look for the one that starts with 600. And then the 3% would be 1.03. So this would be
2.
D, 2D. Yep. Okay, the next one, 1,000, and then increase by 5%. So it'd be our last one. So this would be
3.
3A. And then 1,000, and then 3% would be 4B. Number 5, are the above earning interest graphs increasing or decreasing over time? And why? Use amount of money and time in your answer. Okay, what could we write there? So we know it's increasing, right? Now we have to write why.
You can tell from the lines, and you can tell from the earning part.
Yeah, where it says earns. So the graphs because it's asking about the graphs. The graphs are increasing. It says use money, amount of money, and time in your answer. Are increasing.
I put
What'd you put?
over 1%.
Over certain percentages, increasing by a percentage,
No,
or what'd you put?
it's increasing because it has an interest over 1.
Increasing because the accounts, right? Are earning a percent interest. Over time. So we used the accounts, the money in the accounts are earning a percent interest over time. You may have written something different as long as it goes along with that, and you're answering the question, that's fine. You don't have to change it. All right, so now let's look at the next ones. What do you notice about these graphs? They're all decreasing. They start at a point and then they're going down and they have the curve. It's non-linear. So each one, well, these start at 20% and these start at 2,000. I mean, start at 20,000 and these start at 2,000. So what is this point on our graph going to be? The highest point that on our y-axis, our y-intercept? 20,000. And then our lowest y-intercept would be 2,000. So we've got to know which one increases faster and then which one that corresponds with. So let's start with the 20,000. So we have these two, 6 and 7. So which one depreciates at a faster rate? The 30% is a bigger decrease. So it's going to go faster, right? So this is fast. So this would go with B. And then the 20%, it's still fast, but it's not as fast, so it's slower. So that would be A. And then we have this $2,000 computer, 30% a year versus 20% a year depreciating. So the one that depreciates faster has a bigger number, fast and slow. So the 30% decrease, what would that be? D. And then the 20% decrease, C. Okay, now our function rules. So these were all 1 point something, right? Whenever you increase, because you're doing 100% plus more. So how are they getting something lower than 1? How would you get something lower than 1? Because if you keep it the exact same, that's 100%. So if you decrease it, what will you do? You'll have a decimal. So what we're doing is we're taking 100% and we're subtracting how much we're depreciating by. So on each one of these, you'll do 100% minus whatever that decrease is. Because you're taking it down a notch. So whenever you start running, you kind of start slow, right? And then you build up, and then you're going at your fastest pace. But then toward the end, you start slowing down. So you're no longer going at 100%. You're having to take it down a little bit. So same thing with anytime you depreciate something, you're taking it down, and it's going to be lower than what it originally cost at 100%. So if we have 30% here, we take 100 and we subtract 30, and we get 70%, which is 0.7. So we're taking it away from 100 whenever you depreciate. We're adding to 100 when you earn interest or you're increasing. All right, so what does 6 go with then? Would be, yep. And it's this one right here. So I would say 6B. All right, then the next one, let's see. 20,000 depreciates at 20%. So what would be our rate? You're taking 100, taking away 20%. What would it be? 80. So 0.8. So that's the top one. So this would be 7A. Okay, where does 8 go? At the bottom. So 8D. And then the last one. Let's see. Are the above depreciating value graphs increasing or decreasing over time? It's decreasing. We can see that on the graph. So what can we say about Y? Over time, the value goes down, right? By a percent. If the interest rate from the bank is 7%, the exponential function is modeled by the amount of money over time is 1.07 to the x power. Why is the multiplicative rate written as 1.07? Why would it be written like that? How can we explain that?
Single digit. Because it is increasing by 7%.
So if it's increasing by 7%, why is there a 1 out front?
So it goes up.
Yeah, so it goes up. So we have 100% plus the 7%, 107%, and then we move it to a decimal, 1.07. So it's increasing. All right, so the next one is if the depreciation rate for a car is 25%, the exponential function to model the value of the car over time is 0.75x. Why is the multiplicative rate 0.75? What do we need to write here?
Because it's subtracting.
Because it's subtracting from what?
Because
The 100%. It wasn't me this time. All right, so we would say 100% minus 25% gives us 75%, which converts to 0.75 because it is decreasing. 100% is exactly what you have. If you increase, you add to 100%. If you decrease, you subtract from 100%. All right, that is all for today.